In this simulation, we're going to see the magnetic field of a bar magnet. Here you can see a bar magnet made of magnetized iron placed on a piece of paper. Remember that a compass is a pivoted magnet that will turn and come to rest along a line of force if it is in a magnetic field. Now let's drag the compass across so that it touches the top of the bar magnet just above the N label. Let's move the compass here. Notice how it's rotating. What pole of the compass touches the corner of the north pole of the bar magnet? Exactly, the gray color, which is the south pole. Now let's drag another compass to see how it will be affected by the bar magnet. Let's place it here. Notice that it has a horizontal direction. Let's place this one near the south pole. What pole of the compass touches the corner of the south pole of the bar magnet? Exactly, the red color, which is the north pole. Now let's select field lines to show the complete pattern of the bar magnet. As you can see, this is a non-uniform field because the lines of force do not stay the same distance apart. The curved lines meet at points inside the magnet, which are called poles. Now let's drag a compass along some of the lines to see how it points along them. For example, here, it has a horizontal direction. And near the North Pole, and one near the South Pole. So near the poles, the lines are vertical. However, between the poles, the lines are curved.